All right, so we're starting up with the first lesson here on page 6. And what's the chapter about? Exploring expressions, equations, and functions. What a great class. Awesome class here. What we're going to be talking about first are the expressions. But when you talk about equations and functions, basically, the way I try to think of it now, you know how you have in English, you have letters, words, phrases, sentences? It's kind of like that idea. You have a phrase, you have a sentence, you have maybe a set of sentences, like a paragraph. So we're trying to look at this as we would in grammar because they relate together. So let me ask you this, although this is not English class, do you need to know English for this class? Yeah, and today you're going to see, yes, you're going to need it. Okay, so that's the title, and we're looking at some terms today. So go ahead and write these down in your math notebook. So the first term, which is on that first page of your lesson, is going to be, what is a variable? Does anyone remember what a variable is? What's a variable? Josh?
It can be changed. Wait.
Yeah, you're thinking like maybe science, but it has a similarity to it. Please? Okay, good. And I'm going to put it this way. It's a letter that stands for a number. A letter that stands for a number. So, do we always know what that number is? No. But it's still a number. It's an unknown number. That's a variable. Everyone okay with that? Okay.
Yes, sir.
Then we go to this next term, which is a little bit tougher, algebraic expression. Yep. We're going to get heavy. We went from variable, which is a pretty known term, to algebraic expression, to what did you just say? Okay. Does anyone have a guess, or does anyone know what algebraic expression means? And I gave you a little bit of a hint to maybe help you out. Benson?
An expression of algebra?
Yes, it's an expression of algebra. A little bit more depth to that. Yep. Okay, you're starting to get it. It has to have a variable in it. So it's part of an equation, usually one side or the other. Or it could just be by itself with no equal sign. So here's what I'm going to do. I'm going to give you a definition, and we're going to use that definition to help us out. So we're going to say it consists of one or more numbers and variables. And it's also along with one or more operations. Okay, I'll give you a little bit of time to write that down. That's a technical definition. One or more. Yeah, you're going to hear that a lot this year. So get used to it. Okay, there are some key words. The word numbers, the word variables, and the word operations. Do you know what a number is? Yeah. You've dealt with them for a long time. You've dealt with your favorite numbers, fractions and decimals. Those are also included. Whole numbers, any number. And then variables. If you're like, I didn't know what a variable was before today, I hope you now know it. It's a letter that stands for a number, and you've used them a lot. And then operations. What in the world am I talking about? In arithmetic, like elementary math, you learn about 4 operations. The first one's addition. What's the next one? Subtraction. Then multiplication. Then division. And then we look at, in this past year, and then probably the year before that, 2 other operations that are also part of those 4. Let me give you a hint. when you want to show repeated multiplication. Exponents, we call those powers. Okay, we use powers. And the inverse of powers would be? Yeah, you would say roots. Some of them are square roots, cubic roots, but you call them just roots and powers. Inverse operations. All right, if you have an expression that has numbers and variables and at least one operation, what do you have? An algebraic expression. All right, so let me give you some examples, because some of you are like, yes, mister, I get that, but like you're not seeing it yet. So let me give you an example. X minus 2. Okay, is that an expression? Algebraic expression. Okay, does it have numbers and variables? Okay, at least one of each. Okay, we got it. Does it have an operation? What's the operation? And or? Okay, so here, remember, we see it as subtraction, but can you also see it as addition? Good, so that's check. It is an algebraic expression. Okay, here's another one. A over B plus 3. Is that algebraic? Yes, it has a variable, it has a number. What is the operation?
Division and...
Whoa. I see addition. Where's the division?
A over B.
Right here, A over B. So this is also an algebraic expression. Okay, and then we have, this one's a tough one. T times 2s. Okay, does it have a variable? Check. Does it have a number? Check. Does it have an operation? Which one is it? How many times? Twice. Good. Oh, yeah, right here. Boom. But where's the other one?
2s.
Oh, it's right here. Okay, so the way we see it a lot of times, and I'll get to this in just a moment, is you're going to see it like this. 2 times a variable, 2s. Question? How many of you looked at this right here and said, what's going on, Mr. Ray? What happened? Okay, why do we not use the little x's anymore for multiplication, Riley? I saw that hand. Why do you think we don't want to use that anymore? Okay, Harper? Yeah, because if I made this a little bit too big or too close to one or the other, it can look like multiplication. So although this is an algebraic expression, we don't see that x anymore for multiplication. Okay, good. And we'll talk more about that in a bit. Uh-oh. What about this one? That's complicated. Okay, does it have a number? Does it have a variable?
Yes.
Does it have an operation?
Yes.
Okay, what operations and where? Okay, Walker.
Division and multiplication.
Where's the division?
In between the n and the 2.
Good. Where's the multiplication?
Between the 2 and the k.
Okay.
7 and the m and the m and the n.
Yeah, these are being multiplied, these are being multiplied, and these two products are being divided. So, algebraic expression. So have you ever dealt with algebraic expressions?
Yes.
Yeah, maybe too many times, right? I'm going to say not enough, because we have a full year's worth of it. Okay, yeah, that's a joke. All right. If I had expressions with just numbers and operations, we call those numeric expressions. Why do you think we would call those numeric expressions? Hayes? Yeah, it would be an expression with only numbers. So all of these are algebraic, but if they only had numbers, they would be called numeric. Yeah, numeric. Okay, good. Speaking of multiplication, as one of you brought up, this is a special note for those who may be confused with multiplication and its place in algebra, which it has a huge place. All right, this is how you're going to see multiplication. The most common way is you're going to see variables or number and variables next to each other. That's multiplied x and y, right? X times y. Okay, you're also going to see it x times y. Or you're going to see it x times y. Or you're going to see it x times y. All right, you notice how I said those all the same way? Because they're all the same thing. The most common ones for now are going to be the x and the y next to each other. This one's a nice one, and this one right here. Actually, all of them, really. What are you not going to see as much anymore? What?
The multiplication sign.
Yeah, you're not going to see this as much. You might see it occasionally. You're not going to see that. And I don't want you to use that anymore because it is hard to distinguish, especially if your writing's like, and then you have X, X, Y. And then you have to simplify that. But that wasn't even what you wanted. And you confuse yourself. So make sure that you're good with that. Any questions on multiplication? You guys okay with that? Okay. Is this basic stuff?
Yes.
Very hard. That's not
And what I like about this is like trying to get you ready for Algebra 1, and you guys are already there. Like, I don't think you guys are like wondering, really, Mr. A? But even if you are, let's get it out of the way and really get it clarified. Okay, 2 other terms, and then we'll get into the meat of the lesson. What's a factor? Anybody? What's a factor? Benson? Okay, a number that is being multiplied. That's good. That is being multiplied. All right? Now I need to ask this question, see if you guys are really thinkers. Okay, if numbers are being multiplied, they are called factors. Can a variable be called a factor?
No.
Okay, so I heard yes and no.
Yes.
I heard yes.
Yes.
Okay, who knows why a variable can be called a factor? Because I'm confused. A variable's a letter. Eli? Remember what a variable is? It's an unknown number. So it's like a number in disguise. So can a number in disguise be a factor? Yes.
Yes.
So a number can be a factor, a variable can be a factor. And we'll get into more complicated things. You can even have a sum be a factor.
No.
What's a sum, though? Answer to an addition problem. Good. All right, product. What's a product? Margot.
Multiplication?
It's
No.
no. It's related to multiplication, but what about multiplication?
It's like what comes out of it.
Okay, the answer to a multiplication problem. The answer to a multiplication. And we're going to clarify that term as we go along. Multiplication problem. Okay. So if you know that, you're good so far. Wait, I feel like this is like language arts. There's been terms and sentences and all that. I know, right?
He's going to start up on us again.
All right. Man. All right. Do you need to know English for this class?
Yes.
All right.
All the way.
What you're going to be doing today, you're going to be translating. You're going to be translating algebraic expressions to verbal expressions. You're going to be able to write out what is this algebraic expression using words. And you're also going to be taking words into algebraic expression. You're going back and forth. That's the whole point of today. So a lot of terms, a lot of writing, but that's what today's lesson is about. So this is the first thing. Translate verbal to algebraic. And you guys have heard, I may have told you, but I don't know if you heard it. Math is the language of the universe. Have you guys ever heard that idea?
Yes.
Okay, maybe I said it. The reason we say it's not, guys, I'm not trying to say math is the most important thing you'll ever learn. It's not. In fact, there are more important things than math. Wait, stop recording. Stop that. Okay. There are more important things than math. What is one thing you should study way more than math? And this is coming from the math teacher. Okay. Josh.
The Bible.
The Bible. It really is. Listen. Do you remember Solomon, how he asked, or God asked him for anything, or to give him anything, what would it be? And what did Solomon want?
Wisdom.
He could have asked for wealth, for fame, for popularity, whatever. He could have said anything. And what he asked for? Wisdom. And God in His mercy and His grace says, I'm going to give you wisdom, and with it, I'm going to give you wealth and fame and knowledge, all of that. So there's one thing, if there's one thing you ask for, don't blow it on, I want to be the highest math student ever. Okay, don't blow it on that. Say, Lord, I want to be wise. Because that applies to math, English, science, Bible, PE, your parents, your siblings, life, work, death, birth, everything. Wisdom. Wisdom's everything. So for me as a teacher, I need wisdom. What do you need as a student? Wisdom. So get wisdom. All right, good. Next. Let's look at example 1A. Let's see how this works. How are you going to do this? We've done this before, by the way. It's not new, but it's been a while. All right, what's the phrase on example 1A? It says translate these verbal expressions to algebraic expressions. So what's 1A's expression? Who could read that for me? 1A, Walker.
3 times the number x subtracted from 24.
3 times the number x subtracted from 24?
Yes.
Now, each word matters. And I'm not saying that because, oh, look at the importance of my book. Each word matters. If you don't write the correct word, or you don't see the correct word, or read the correct word, it's wrong. It's going to throw you off. Okay. How would you write 3 times the number x?
I'll answer
Okay.
that, but I do have a question.
Yeah, go ahead.
Why didn't they write out 3, but they put...
Didn't write out 24? Yeah, you're going to see it mixed. You're going to see 3 in numeric form, 24 in written out. It's okay. What I want you guys to focus on are these like key words. But you can write x is x, 24, and you could have put 3 there. Totally okay. Yes, Lizzie. I see that hand. How do you write 3 times the number x? Okay, 3x. How many of you guys would have gotten that on your own? Good. Okay, some of you are struggling. No. All right, 3x. There's something I need to write right here after the 3x or before the 3x, I don't know. Subtracted from 24. What does that mean? How would I translate that accurately? There are 2 ways you can think of it. One way is correct, one way is incorrect. I mean, that's how clear cut it is. Okay, Ellie, what would you do?
You have to put 24 before the 3x because it's being taken away from 24.
But I thought it would have been this.
But that doesn't make sense because it says subtracted from 24.
Wait, they're not the same thing?
No.
I thought commutative property.
No.
Okay, there's a key word in this little phrase down here that tells me it's this, not that. What's the key word? Josh? From. Subtracted from. Okay? So you have this quantity taken away from this quantity. So it's 24 minus 3x. This is my answer. Okay? By the way, what part of speech is from?
What did you just...
What part of speech is from? Preposition. It's a preposition. This is a prepositional phrase. Did I scare you guys? Because like, wait, we're not thinking of that. Okay, it's a preposition. Maybe I will never ask that again. All right. 1B. Beth, can you read 1B, the problem?
5 greater than half the number.
Than half a number t. All right. How would you write 5 greater than? By the way, there are no inequalities on this lesson, so don't think, oh, wait, is that the greater than symbol? No. We're talking about expressions. Those are inequalities. So that's like a sentence. This is a phrase. So how would you write 5 greater than? How would you write 5 greater than? What does that mean? 5. What?
5, and then the sign.
So again, you're maybe thinking like the greater than symbol, but they're not inequality. These aren't inequalities. So what does greater than mean? What does that usually mean?
Oh.
Taylor?
Add 5.
5 plus something, or something plus 5. All right, good, addition. What's half a number t? Half a number t. I don't know what t is. So how would you write half that number t? If you don't know what it is, I don't know. Eli? Okay, so good. I'm glad you brought that up. Some of you thought of it like this. Some of you thought of it like this. Who's right? Who's wrong?
Both are right.
Both are right. Now, how many of you wrote it or thought of it like this? Or you could have even written 1/2 t plus 5. Either one of those. How many of you thought of it like that? Okay, so there's a split. The reason we need to know both of them is because, let's say, Beth, you really like this way. You hate 1. You have a problem with the number 1. I don't know why. Something in her past. But she really wants to avoid the number 1. So she writes it this way, but there's only one problem. James, I read it like this, 5 plus 1/2 t, and so he marks her off. She didn't have a 1, but is she incorrect? No. She just wrote it a different way, which is the same thing as this. They're similar, equivalent. Okay, so you need to know it like this and like that, because you can see it either way. Does that make sense? Like, even if you don't like one way, you got to know both ways.
That does make sense.
Okay, good. That makes sense.
To make it different from the added sign.
Oh, I see. Make them bigger?
You can like curl the bottom.
Oh, yes. So curl this up.
Oh, yeah.
Thank you. Write that in the comment section of my video. All right. I will delete any bad comments. All right. Translate algebraic, the second part and last part. Translate algebraic to verbal. This was brought to you by Mitchell Road Christian Academy, home of the Eagles. All right. Actually, you know what? I did that in the last class, but I didn't record it. Now I recorded it. Okay. So now that's going up. All right. That's okay. And that's going up. All right. In these examples, what you're going to be doing is they're giving you the algebraic expression, and you have to translate it to words. That's what it means by verbal. So we have 3 plus b, and then we have the division by y. Okay, here, when you're writing this into words, you got to be careful, because you may write it in a way that's super, super close to what it's saying up here, but it's off. So when I read your phrases, I should be able to come up with this algebraic expression. Okay, order of operations, what would you do here? We'll talk about that more specifically, but what do you remember from order of operations? You would do what first?
Sorry.
That's okay.
I was thinking of the answer.
Oh, okay. So what would you do first here if you knew all the numbers and all that? You would do what first?
You would, I don't know.
Okay, Walker?
3 plus b.
You would add these up first, right? You would do this first. Then you would divide that sum by y. Is that good? Do you notice the word I use, sum? Okay. This is how I translate it. The sum of 3 and b. Okay, do I know what the sum of 3 and b is exactly? Like, do I know what b is? No. So I really can't combine those anymore. But I know if I could, I would add those up, and then what would I do? Divided by y. Okay? Why would it not be okay to do this? 3 plus b divided by y. That sounds really close to what I just said. Hayes? Okay, on this problem right here, imagine the parentheses were dropped. Wouldn't I do the b divided by y first, then add 3?
Yes.
But is that what I'm doing in this actual problem? No. So I'm changing it up if I wrote it down incorrectly. All right. Example 2b. Example 2b. Last one here. We're almost done. On this one you could do many ways. 5y plus 10x. Okay. What's being added? Oh, sorry. Order of operations, what would you do first? You do 5 times y. What else would you do next? or at the same time 10 times x. And then what would you do? Add. So you're doing the addition last? Okay. That's okay. What you would do is this. You would find out what this is, find out what that is, and then add it together, correct? So you would find the product. That's why we looked at that word product. The product of 5 and y. And you could put added to or plus. I'll just do plus. Plus the product of what? 10 and x. Good. There you go. 10 and x. That's done. You could have said, oh, the product of 5 and y added to the product of 10 and x. I'm going to leave it like that. Too much variety can confuse us. But do you guys get how I got this? Okay.
Yes.
All right. Stop recording.